Okay, chemistry students, here we are with lesson 7.4, where we're going to look at mole to volume conversions and also mixed mole conversions, where we have you converting two or more things in the same problem. So the first objective is we need you to recognize the equivalence for molar volume of a gas at standard temperature and pressure. And so we'll explain what we mean by standard temperature and pressure. Second objective, given the volume of a gas at STP, that's standard temperature and pressure, calculate the number of moles of gas. And then the reverse, given a number of moles of gas, determine its volume at standard temperature and pressure. And lastly, to perform some mixed mole calculation problems that might involve masses, particles, or volumes, and converting back and forth from moles. Let's get to it. So, Avogadro's big contribution to the mole was he recognized way back when you have gases at the same pressure and temperature, if you have equal volumes of any two gases, they have equal numbers of particles in them. And we'll cover this a lot more depth when we do our unit on gas laws, but that was his big contribution. So later, chemists then went and defined some standard temperature and pressure conditions, and this is arbitrary conditions that were picked so that when you say STP, then we know we're comparing a given temperature and a given pressure. So what are those conditions? The pressure is 1 atmosphere, which would be the average sea level air pressure of Earth, and the temperature was chosen as 0 degrees Celsius.
So this way everybody has the same starting point, and then they can convert to any other condition if they need to. So this was very good. In science, you kind of have to have those, marking points. And then last, the molar volume of gases at STP was 22.4 liters. That's just a physical fact.
Here's a box. It's roughly like 11 centimeter or 11 inches square, and that box at standard temperature and pressure has 22.4 liters of volume, and there's your temperature and pressure conditions at standard temperature and pressure. So this is called molar volume of a gas. 1 mole of gas at STP equals 22.4 liters. So there's our equivalence relationship, relates moles to volume of a gas. Now we can convert back and forth between them.
All right, let's do some practice. All right, so the first one is that we know the volume of 0.554 moles of helium gas at STP. So first, we always set up our given. So we have 0.554 moles, and we know that there are 22.4 liters per mole.
So we're going to use the conversion factor. We want to go from 1 mole.
We know that 1 mole is equal to 22.4 liters at STP.
4 liters. And, the problems are going to say at STP because until we cover gas laws, we really can't deal with any other conditions.
Gas laws, that's going to change.
That'll change. But for now, unless, it's going to say STP in all of the questions.
So we do the math, and it comes out to be 12.4, and that's the width.
With 3 significant figures.
12.4. And that comes from the measurement in the question. 0.554, remember 22.4 and 1 mole are all given, so they do not affect our overall calculation.
So we're just using the equivalence relationship of 22.4 liters of gas is the same as a mole of gas, and we can convert back and forth between moles and liters. Right. So now in the next one, we're going to reverse it. We're going to ask how many moles do you have if you have this many liters of hydrogen gas at standard temperature and pressure.
All right, so again, we set up our given, 45.32 liters. And then you have to...
We'll fence post this one.
And then you have to do your conversion factor. And since liters was given, you have to put liters on the bottom, so that's 22.4 liters. And then, of course, 1 mole on the top. This now converts us into moles. And using proper sig figs and checking our units to make sure they cancel properly, we find out that we have 2.023 moles of hydrogen. Remember, hydrogen's a diatomic. There were 7 of them that form a 7. That's nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and astatine, plus hydrogen gas are all these diatomics, and that's going to come up in the next slide, actually.
And one other thing, it does specify the gas in both of these. However, since as long as we're going just moles to volume or volume to moles,
Doesn't
the
matter.
gas really doesn't matter because the molar volume is the same for all gases.
But again, if you go to grams.
But when they ask for mass, then, that's where we're going to go next. So let's go there.
All
So
right.
now what we're going to do is some mixed conversion practice. So we're going to put everything, this whole map in
the whole
place.
left side of the map.
The whole left side of the map. So when we're dealing with a given substance, we can give you any one of these four things: particles, volume, mass, moles, and ask you to change it to any one of the other ones. So let's do two examples of how this works. And it's just combining things that we've already done in a series of conversion factors. So here's problem one. How many grams of chlorine gas will you have if you have 35.6 liters of that gas at STP? So what's our given?
35.6 liters.
So we're starting at volume, and we're asked to go to mass, grams.
Okay.
So our map is volume to moles,
moles
to mass.
So
Okay.
first you write down our given.
35.6 liters.
And then we have to use our conversion fact for liters to moles, since that's where we're going.
So it's 22.4 liters. I want to get rid of the liter unit, change to moles.
All right. And then
And again, like Mr. Hunter said last time, you don't stop here.
You can,
but it's easier really to get all of the conversion done and then crank the math out all at once.
so then 1
So we have
mole.
1 mole.
And now the one thing you have to know about chlorine gas is that chlorine is Cl2. It is a diatomic. It is one of those 7 that form the 7 on the
So
right
that
side of the
means-
periodic table.
That's going to affect its molar mass,
So
right?
instead of being 35.453, like 1 chlorine would be, it would be 70.906. And if you miss that, you'll get the wrong answer by about half.
Yeah,
So-
you'll have exactly half as big as what you should. So a mole of Cl2 has a mass of 70.906 grams. And I
per
forgot to
1
write
mole.
grams up here.
And then from there, you just hit enter.
Let's check our units. Liters divides out, moles divides out, and we end up at grams. So now
It comes out using proper sig figs at the very end, 113 grams.
of
Chlorine.
Cl2. Okay, so again, it's just combining in 2 steps the things we've already done.
Yep. All right, last practice problem together here. We have 10 liters of nitrogen that are contained in a bottle at STP. Do we know how many molecules of nitrogen are in the bottle?
So now we're at,
It's okay.
volume, and we need to go to moles and then to particles because molecules are particles.
All right. So our starting given is 10 liters. Notice there is no decimal at STP. So we're going to do our conversions. So we know that there are 22.4 liters in 1 mole. And then nitrogen is a diatomic. So in 1 mole, we know that 1 nitrogen is 14 grams. Whereas,
Oh wait, we're going to particles.
Oh, right, yeah, we're going to particles. So 1 mole is 6.02 times 10 to the 23rd. Good catch. We could do that too, but you know. So, while you check the units,
And
I'll
that's
do the math.
molecules. So let's check our units. Liters divide out, moles divide out. And so MOLE, remember, is abbreviation for molecule. So that should be the correct number of molecules. 10 divided by 22.4 times Avogadro's number.
turns out to be, with the correct number of sig figs, 3 times 10 to the 23rd. Because 10 is our measurement, and there is only 1 sig fig because there is no decimal. That trailing 0 is not significant. So it's not significant, and it's molecules of N2. So this finishes out the last of our mixed conversion practice. The next step now is to talk about, well, this is the next unit now, if you're going on the stoichiometry, is to talk about things like reactions, in which you go from one type of thing to a whole different atom or molecule.
But you can still use moles to get you
Yes.
there.
So
we'll work into that.
that's just a peek into the future. In the meantime, have a good night.
So for your post-video questions on this lesson, I have one that's a mole to volume conversion. That's the first one. 3 moles of gas is placed in a cylinder with a movable piston. That will allow the volume of the gas to change. So what volume will that 3 moles of gas occupy at standard temperature and pressure conditions? And the second one's a mixed conversion. If you react vinegar with baking soda and the reaction produced 16.2 liters of CO2 gas, carbon dioxide gas, under STP conditions, what would be the mass of carbon dioxide produced? So you're going to have to go from volume to moles and then from moles to mass. So it'll be a 2-step process. So give those a try and we will discuss them next time.